Assalamu alaikum students. We will study today measures of dispersion. Before the university gets shut down, I solved this problem. I taught you how to calculate z-score. This problem is based on z-score. Let's read out the question. Suppose that the midterm test scores for 100 students in a college business statistics course exhibit normal distribution with a mean of 70 and a standard deviation 5. So here the first question is asking how many students had test scores between 60 and 80. Here you can see the mean is given 70, so that means x bar, which is sample mean, or if you call it population mean, then mu denoted by mu is 70, and standard deviation, if it is sample standard deviation, then s, and if it is population standard deviation, then it will be denoted by sigma, which is 5. So we'll convert the test scores, that means this 60 to 80, to its corresponding z score. So here you can see the formula for z score is xi minus x bar divided by standard deviation, that is s. So here we are converting 60 to its z score. 60 minus x bar is 70 and standard deviation is 5. So we will convert 80 to its z score. So 80 minus x bar is 70 divided by standard deviation 5. So if you calculate the z score is between -2 to +2. Because the values are same. Here you can see if you take the absolute value of z's, here we have two z values. If you take the absolute value of z's, that means if you remove the minus and plus sign, both the values are identical. That means both the values are same. Absolute values are same. There is 2. Because of that, we can use the Chebyshev's theorem. Chebyshev's theorem says that at least 1 minus 1 upon k square into 100% data falls within that category. So now we can see here z value, absolute value of z is 2. That means in Chebyshev's theorem k is 2. That means here 1 minus 1 upon 2 square into 100%. If you calculate it, you will get 75%. That means at least 75% students had test scores between 60 to 80. Now we will go for empirical theorem. Because we have these z values are from -2 to +2, that means this is a 2 standard deviation limit. We know that within 2 standard deviation, according to empirical theory, within 2 standard deviation 95% data fall. That means approximately 95% students might have test scores between 60 to 80. Now part B. In part B, the question is asking how many students had test scores between 58 and 82. Right. So test scores 58 to 82. So we need to convert z score for these marks. So now you can see the x bar is 70 and standard deviation is 5. So we convert 58 to its z score, and similarly we convert 82 to its z score. So we get -2.4 to +2.4. Because the value, if you remove the plus and minus sign, both the values are identical. Both the values are same, 2.4. But because of that, we can use Chebyshev's theorem. Since the values are same, we can use Chebyshev's theorem. Right. So at least 1 minus 1 upon k square into 100% data falls within that range. So that means 1 minus, here k is 2.4. So 2.4 square into 100%. So that means 82.638% data. So that is at least 82.638% students had test scores between 58 to 82. Now to get the empirical value, that means to get the empirical value, we need to use the z table, because here the values are not round up to 2 or 3. Here the values are in decimal points. So that means we need to use the z table to get the empirical value. So we will move to next page to find out the values now. Right. So here you can see the marks limit was between 58 to 82, and the corresponding Z scores are minus 2.4 to plus 2.4. So to find out these one, we need to first get these area. That means when the value, we need to find out the area when the value of Z is less than or equal to minus 2.4. That means we need to use the table where the values of Z's are negative. You can see we will first use this table where the values of Z's are negative. Where the values of Z's are negative. You can see in the right hand side of the table the values of Z's are all negative. So in our question the value of Z was minus 2.4. So that means we need to find out the right row for minus 2.4. So this is the right row for Z value minus 2.4. This is the right row for Z value minus 2.4. So that means we have minus 2.4. That means minus 2.40. So that means we get the right value for this Z score is 0.0082. That means the right value for this Z value minus 2.4 is the area is 0.0082. So let us put it the value there. So that this area is 0.0082 for Z value of minus 2.4. Right. So now we will go for the positive Z value, that is 2.4. When the Z value is less than or equal to 2.4, that is Z value is positive. That means in that case we will have to use the table where the values of Z's are all positive. That means where the values of, you can see on the left hand side of the table all the values of Z's are positive. So we need to find out the right row. We need to find out the right row where the value of Z is 2.4. You can see here this is the column for Z and this is the right row for 2.4. So you can see the value of the area is 0.99, area is 0.9918. So that means here the area is 0.9918. Right. So you can see when the Z was less than or equal to minus 2.4, this portion of the area is 0.0082, and this portion of the, when we use Z is equal to 2.4, that means from here to here, all the area is 0.9918, and from here to here the area is 0.0082. But we need only the area of the shaded portion. That means first we need to get all the area. That means from here to here all the area, and from this all area we will deduct the small portion of the area. That means 0.9918 minus 0.0082. 0.9918 minus 0.0082, we get 0.9836. As you can see, 0.9918 minus 0.0082, 0.9836. That is 98.36%. That means approximately 98.36% students had test scores between 58 to 82. Now we will move to part C. In part C, the question is asking how many students had test scores between 61 and 79. So we will get the Z score value for these both marks. So we can see 61 has been converted to Z score, 79 has been converted to Z score, and we have got minus 1.8 to 1.8. So Z values are almost identical except the plus minus sign. So that means if we ignore the plus minus sign, Z values are same. So that means we can use the Chebyshev's theorem to get the idea. So at least 1 minus here, because the Z values are same except the plus minus sign, so this 1.8 is the k value or the z value. That means minus, here the k is 1.8. So if you calculate it, we get 69.135%. That is around 69% students, at least 69% students had test scores between 61 to 79. Now we will get the empirical value from the z table. Because the z values are not round to 2 or 3, we have to use to get the empirical value, you need to use the z table. So let's go to z table. First of all, we will get the negative value of z. That means we will need to find out the area where the value of z is negative and less than or equal to minus 1.8. So first we will find the table where the values of z are negative. You can see the values of z are negative. You can see the values of z are negative. So we need to find out the right row for the z. That means here the value of z is minus 1.8. So that means this is the column for z and this is the row for minus 1.8. So we can consider it like minus 1.8 means minus 1.80. So that means this is also the column for 0. So that means minus 1.80. So the right area is 0.0359. So the right area is 0.0359 when that means this is this portion, area of this portion is 0.0359. That is from here to here area is 0.0359. Now we will look for the positive value of the z. That is, we will use this table now where the values of z are positive. You can see on the left hand side of the table, values of z are all positive. Here you need to find out the right row. In our case the value of z is 1.8. So this is the 1.8. You can see this is the column for z and this is the right row of z, 1.8. So let's see, this is the value is 1.80. So this is the 0 column. So the right area is 0.9641. 0.9641 is the right area. So you can see 0.9641 is the right area. But this 0.96 area is from here to here. We don't need the full area. We only need the area up to this shaded area from here to here. So what we will do, from 9641, that is from here to here, we will deduct from here to here, that is 0.0359. So to get 0.9282, that is 0.9282 is the answer. That is 92.82%. That is, if we round it, it is 93%. That means approximately 93%. That is approximately 93% students had a test score between 61 to 79 according to empirical rule.